This video is focused toward the basics of normal distribution. Then in the next video, we are going to solve a bunch of problems of all kind, including using Excel. So first of all, discrete versus continuous distribution. Discrete distribution where you can count number of cars, number of people, when you toss a coin, etc. That's a discrete distribution. Continuous is measurement. We measure temperature, we measure weight. We don't count weight. We don't count temperature. We measure them. So that's continuous. And normal distribution, of course, is symmetric. So the mean, median, mode are always equal, which means they all are right here. So this is the mean, weight-wise, half and half. Median is half here and half there. And mode is the most number, which is right here. That's the most number here. So mode here will be more like right here. That's the mode. That's the mode here. Though we don't use mode in statistics much really in general. So now let's move on to our next stage. Relationship between areas. Well, we got areas here 1, 2, and 3. So what are the relationships? Now remember, the whole thing is 100%, right? So this is 50% and this is 50%. So really, once you know one area, you can figure everything else out. If it's a left side, exactly same calculations. Now we are going to ready to solve problems slowly and slowly. So we have a normal distribution whose mean is 120, sigma is 30. So here it is. Mean is 120 and sigma is 30. Now our point is 160. Okay. So how far apart this point is from 120 from the mean? Well, it's 40, right? 40 days, $40, 40 pounds, 40 kilograms, 40 pennies, whatever that is, 40. But sigma is 30. So we divide, okay, this is got wrong here. That should be 30. Okay. So we divide 40 divided by 30. That gives 1.33. So we are going to say that our point 160 is 1.33 sigmas from the mean. Or the z-score is 1.33. And that's it. That's how we do. Now here is our table. Now when you look at the probability table, Z table for instance, you look at the picture that comes with it. Very critical. This picture tells us that all these numbers that you see here, probabilities areas, are these numbers from mean to this point. So if you have 1.33 sigmas from the mean, this table gives you area from the mean to that point. That means from there to there. And that will be 1.33 is 1.3 and 3. 0.4082. What's 0.4082? That's the area from there to there. Okay. And now we can play the game. I want to find this area, that area. We can do all of that stuff now. So what's the probability of X 160 or more? Well, 160 or more will be this side here, right? And we know the whole thing is 0.5 from there to there. This is 0.4082, so this becomes 0.0918. So what's probability of X less than 160? Well, that will be all the way from here to end, left side. Well, this we know is 0.4082. This we know is 0.5. So 0.5 plus 0.4082 is 0.9082. So 90.82% probability it will be less than 160, and but 9% probability it will be more than 160. Now here is another situation. Same problem, and there's a table. But the picture with this table is different. The picture now is covering all these areas, which means all these numbers are area, gives you area from this point all the way till there. Now if you think about it, the difference between our previous table and this will be 0.5, because this whole area is 0.5 plus this area. So all the numbers you see here will be 0.5 plus the previous numbers in the previous table. This is it. So now we want to find the z-score is 1.33 like from the last slide. So what's the area? Well, less than or equal to 160 is 0.9082. 1.33. 1. 30313233, 0.9082. So this is 0.9082 from there all the way this side here, from the table directly. In the previous table, we would add 0.5 to it. Now what's more than 160? Well, if this is 0.9082, this will be 1 minus this whole area. That will be 0.0918. So the point is, if I get this table or if I get this table, doesn't really matter. So this is simply introduction, the basics, and the next actually will be actually doing it. The next video.